Welcome to the very last problem in this test. We're doing, as you know, we're doing JEE 2025 paper 2. If you've watched my previous videos, and I am happy to have made all the way to this question number 16. Okay. All right. So now, first thing I want to say that this is a Doppler effect of sound waves problem, and you definitely should expect this. I mean, even if you don't get one sometime, but this is like such a common occurrence in these tests. Physicists love Doppler effect, okay, both for sound and light. So, but this is just a sound. So, so here is a frame with respect to these guys being observed. Okay. In this, so this is a fixed frame, some air, and sound waves travels. So they give you the speed of sound to use this. All right. They'll tell you that natural frequency, the transmitter is transmitting. Frequency is 660 hertz, and this is a receiver. So depending on the relative motion, the receiver will get a higher frequency, lower frequency, and they seem to be pulled the same angles apart. So think about what will happen when they come together. They're they're going towards each other. That will be the highest frequency that the receiver will. So there's a situation where, I mean, just down below, not in. It's like it's gonna come down like that, cut down below here, and it will going, and at the same time this guy will be going going this way. So they're both going towards each other, and this guy is still emitting at this. This always emits at this, but this will detect at some receiver will be not the same as that. So this is the situation which will be max, and they'll go and then swing back, and there will be time that this will be going this way and this will be going that way, and then at that time a receiver will receive min. Now these are the V with respect to this frame. This V is with respect to that frame. Okay, so let's say this is V transmitter, V receiver. The formula for F the receiver will receive, it'll be F transmitter, and let's be V with a V of the sound. Okay, so you are going to have we'll say towards and away. Okay, so this is like a towards each other, and this is away from each other. V plus minus V of the transmitter. So these speeds are with respect to this frame. Okay, divided by V minus plus V receiver. So these are speeds. These values are speeds, and the plus here and the minus here. This combo will be when towards, and this minus this plus will be away combo. So just wanted to remember it. Or if you if you want to actually use the x coordinate like this, is very easy to write v plus vtx v plus vrx, and you can see that already the signs are kind of included in there because the x component. So this guy is positive, this guy is negative, and this guy is negative. So negative sign picked up, and this guy is positive. So this is captures it if you just do x. But we're gonna do this. This is a more standard one with the sign convention. Okay, so we need to figure out the speeds. We don't need to work out both of them because the angle is same. So speed is just do energy conservation. So we want to pick the speed at the bottom. That's the level, let's theta 0, and this is where the bottom level is. So this is the height that has dropped. This is L, and this part is L cosine theta. So this much potential energy dropped will go as half mv square. So m just cancels out. This gives me v is square root of 2gh, and h is going to be, this whole thing is L, so L minus L, so h is simply L minus L cosine theta, and so this is just going to be square root of 2gl 1 minus cosine theta, and this is theta 0. Some values are given. Cosine of theta is 0.9, and L is 8 meter. So so this will just become square 2 times 10 times 1 minus 0.9, 2 times 8. So this is 0.1, that kills 10, 16 makes it 4. So just looking at the speed here. So I didn't, that's why I didn't put minus sign there. Means ignore minus sign when it took a square root over there. So it's 4. So this guy will be 4. So this form becomes simply, let's take another ink. So F receiver will see 660 times plus and minus combo plus, so this will be 330 plus 4, 330 minus 4, and so this is max. Min will be 660, 330 plus 4, minus 4, 330 plus 4. You can see that's the minimum we can get by using these signs. If you get confused about signs, you can say what will make this larger, which sign where. So you need a plus to make it larger in the numerator, minus to make it larger in the denominator. And that's the way you can, sometimes it's very easy to, especially in the stress of the test, you say, look, what's plus, what's minus? Just use a logic. I'm going to get this guy largest. What will make, what choice of signs will make it largest? What choice of signs will make it smallest? Okay, you can do that logic. And you can see that you can work out the numbers. So I have worked out the number earlier, and I think this is my numbers. I just worked out the numbers. 76.2 and 644.2. So max minus f min, whatever at the receiver, at the detector, is the difference of these two is 32. This gives me 32 hertz. So that's the answer. Well, maybe you say, hey, you know what? I really put numbers too early. Let's see if I can do another way. So here is another little detour. Already solved the problem. Problem is solved. So I just want to do a little detour. FR max, FR min. I just want to calculate that directly from these formulas. So if you have a FT, you have a B plus, let's call this guy V prime. V prime over V minus V prime. V is the speed of sound, minus V minus V prime over V plus V prime. And I want to first simplify before I put the numbers. So denominators multiply V minus V prime, V plus V prime, and this V prime square minus V minus V prime square. So that's I got, and denominator will be so you can say it's V square minus V prime square. This is 4V prime. And it may be, I don't know if this is easier to do than just do this guy. I don't think you buy much going this route in terms of time. I would just do this route quickly, get done. Okay. So, but there is sometimes you have a, one has a inclination to see if by going to the final answer just in a symbol form leads anywhere, but actually in the case of this kind of case, it doesn't actually. So it's like, and you have a 4 times 330 times 4, and then I've got 330 square minus 4 square. You might say, hey, you know what? It does buy me something by saying I'm going to just say this square is so much bigger than that I'm going to ignore this. Just ignore this here. So ignore this. So that give me approximate formula. So one of these 30 goes away, and this just becomes 2 times, and that's also gives you 32. You see, I mean, I ignored this because squaring this actually gives a very large value, and usually these guys are very small. So if you are more fan of doing that way, more power to you. But if you just want to kind of get done, that's okay too. Yeah, I've actually done both in my tests, so I'm not so keen on which one I'm gonna prefer. It all depends on what kind of numbers you get. So if I was thinking that b prime square was going to be much bigger than just tiny amount like that, I might do it that way. But if b square is very small, like compared to this, I'm expecting that, then I just go this route. All right, that's all there is. And I will probably put all of these videos in one long video for paper 1 and one long video for paper 2, and probably I'll post it also, so that if you're studying the whole test at one time, you might have just one place. Right now I have one videos at a time, so this way I can actually do much more thorough, just study one problem at a time. Now I have a request that if you haven't subscribed, can you please subscribe to this channel. If you like this kind of detailed explanation, some advice like this, how to do well in this kind of tests, you can leave comments, etc. So appreciate it. Take care. Bye.